Hello, my fellow mathematician. Welcome for Calculus for Beginners. This representation it is applicable for those who are beginning their calculus. And today we are going to look at the integration. And the integration we are going to study here, it is the integration of a simple function. A simple function of y is equal to x. In the other ones, a polynomial function in terms of x. That is what you are going to consider. We are going to derive the area under the curve. How do you obtain area under the curve? So one of the uses of integration it is to find the area under the curve. We are going to do that, and also we are going to give some examples of the same of the area under the curve. And then we are going to see how integration is applied in determining the velocity and and displacement. We are going to see how we obtain velocity from acceleration. So we integrate acceleration to get velocity, and we integrate velocity to get displacement. So kinematic has to do with the study of bodies which are in motion. So that is what we are going to consider in our today's study. Stay tuned and let us study together, and I believe you are going to benefit throughout this study. Welcome. My fellow as we define integration as the process of finding functions from their gradient. So when you are given a gradient, or what is referred to as the derived function, you get the function from the gradient or the derived function through integrating. Now, in general, if you are given dy over dx is as equal to x power n, so to integrate this, what we do, we add 1 to this index, n plus 1, and we divide by the result. The result is n plus 1 plus c. C is a constant. Now, in this case, c is a constant and n is not equal to -1 here. N should not be equal to -1 because when we define a number by -1, it will be undefined. So c is referred to as arbitrary constant since it can take any value. It can take any value. Now, we want to look at the example. Here you are given integrate the following expressions. So you are given a 2x power 5, b you are given x power -2, c you are given 5x power 5 minus 2x plus 4, and here we have x power 1 over 2. So to start with, for number a, what we do to start with for number a is that you write it as dy over dx is equal to 2x plus 5. Then to integrate this, what you simply do is you want 5 plus 1, and you divide here 2x times x 5 plus 1 divided by the index, which is 5 plus 1 plus c, which is equal to 2, which is equal to 2, which is equal to 2, which is equal to 2x power 6 divided by 6 plus c. We can here simplify by 2, by 2 1, and by 2 3 to get than x power 6 plus c. The next one, part B, we are given dy over dx is equal to x power -2. So to do that, we are going to increase the index by 1. So -2 plus 1 divided by -2 plus 1 plus c. So that is what we do. Of course, -2 plus 1 is -1 divided by -2 plus 1 is -1 plus c, which is equal to negative x plus c, which can be written as negative 1 over x. You can take this down. So this will be negative 1 over x plus 1. When the index is so we are using this rule here. If you have x power n, it is the same as 1 over n power negative 1, meaning that x power negative n is equal to 1 over x power n. So if the index is negative, when you take one reciprocal of it, it becomes positive. And if it is positive, when you take reciprocal of it, it becomes negative that way. Yeah, so this is x power negative n. And this is x power negative n, which is equal to 1 over x power n. That is the rule we are applying there. Now, this other example here, we are given dy over dx is equal to 5x power 5 minus 2x plus 4. To do that, we are going to integrate this. Here, we are going to add 5 times x power 5 plus 1, this way, divided by this index, which is 5 plus 1, minus 2 x power 1 plus 1 divided by 1 plus 1, plus 4 x power 0 plus 1, this one here. Any number power 0 is 1, so that is where you have written x power 0 plus 1 divided by 0 plus 1, plus the constant. Here, we are going to have 5 plus 1 is 6, power 6, 2 divided by 2, here will give us x squared because of 1 plus that. X power 0 plus 1, it will give us x power 1. X power 1 is the same as x times 4, so it is 4x plus the constant. So that is how you handle that case. Next, we want to look at what is called the particular equation. We want to look at something called the particular equation. Now, here, we want to see how to find the equation of a curve whose gradient function is given by dy over dx is equal to 2x plus 3, and it passes through this point 0, 1. Now, particular equation, it is whereby now you are given more information on how to get the constant after differentiating. So to do that, what you do, it is very simple. So first of all, you integrate this gradient function. After integrating here, you will have this is 2x power 1. So you want 1 divided by 1 plus 1 plus 3x power 0 plus 1 over 0 plus 1 plus that. So our curve will be x squared plus 3x plus c. Now, to get the value of c, we substitute the given condition. The condition given is this one, that the curve passes through 0.01. So we substitute it here this way. So our y is 1, our x is 0. So here 0 squared plus 3 is 0. So 0 squared is 0, and 3 times 0 is 0 plus c. So meaning that c is equal to 1. Once you write it like that, now you substitute. So the particular equation is y is equal to x squared plus 3x plus 1. Substituting the value of c in this curve there. So that is what we are going to get. So the second equation, find v in terms of h if dv over dh is equal to 3h squared plus 4, and the v is equal to 9 when h is equal to 1. So to do that, first of all, we are going to integrate this equation with respect to h. And when we integrate, we are going to find that here it is 3h power 2 plus 1, which is this one, 2 plus 1, you divide by the index. So once we integrate this is 4h power 0 plus 1 over 0 plus 1. We are going to get h cubic plus 4h plus c. So to get the value of c, we substitute this condition. H is equal to 1 and v is equal to 9. So we use this. We are going to substitute here. Where you have v, you write 9. Where you have h, you substitute with 1. H is equal to 1. H it is given there, it is equal to 1. So 1 cubic, it is 1. This one. 4 times 1 is 4. plus C. So this is 5. C is equal to 9 minus 5. This is 5 here. 1 plus 4 is 5, as so. Then you come to this. V is equal to h cubic plus 4h plus 3. You come and substitute your value of h there as shown there. So the particular equation is this one. So we want to look at another example whereby now you have a curve whose gradient function is this one, which gradient function is x squared minus x plus 1 over 4. And there's a stationary point at y is equal to 1 over 6. So we want to find the equation of the curve. So we know at the stationary point, the gradient is equal to 0. So what we are going to do, we integrate this to get x cubic over 3 plus x squared, that one, plus x over 2 plus c. So then we are going to find that c is equal to 1 over 6 when x is equal to 0. At x is equal to 0, then we are going to find that our c is equal to 1 over 6, and this is the curve which we obtain. Next, we want to look at indefinite and indefinite integral, and we are going to consider this curve, the curve shown here. We are going to consider this area bounded by line x is equal to a and the line x is equal to b. So there are two ways of estimating this area under the curve. One of the ways is whereby we subdivide this area into equal rectangle. In this case, in this case now, in this case, we subdivide this region into equal number of rectangles. In this case, as you can see here now, our area will be underestimated because there is a section which is being left here. There is a section which is being left here. If you consider this area here, we say this is figure 1, and this is figure 2. In figure 1, in figure 2, you can see there is a region being left here. So this is underestimation. Now, another way is dividing it into these equal rectangles as shown here. And when you consider this figure 3, when you consider our figure 3 here, this is over. We are overestimating here. This is overestimation. Because if you consider this figure here, this area is more than the area here. The shaded area here is more than this area. And in this case, the shaded area is less than the required area. This is less underestimated. This is more overestimated. Now, to overcome that, what we can do, it is to subdivide this region into smaller rectangles, as many as possible, such that the height of those rectangles can be assumed to be equal to y. And now we take the small change. We take that now our width of this rectangle is delta x here. Now, the area of a rectangle is length which is y times width. So the area of each strip is length times width. What we are calling strip here, it is the rectangles which we subdivide our region. We subdivide our region into number of rectangles. So each of the strip will have this area. It will have the area given by y is equal to delta x as shown here. Now, the area between x is equal to a and x is equal to b as shown here. X is equal to a at this point here. Our x here is a and there it is b, or even as shown here. X is equal to a and x is equal to b. Now, the area now it is the sum. We add all these rectangles and we use the symbol for addition. we add. This sum symbol here means summation. So you're adding from x is equal to a all the way to x is equal to b of these equal rectangles, which we have subdivided our region into. This region, equal rectangles, are shown here. So when we do that, when we sum, now, we take the limit as the width of this rectangle becomes smaller and smaller as it tends to 0, written this way, as delta tends to 0, the summation will be equal to the integration from a to b of y with respect to dx. Y is the curve given. Now, in this case, a is referred to as the lower limit and b is referred to as the upper limit. Now, so in case you are given the boundaries, these are the boundaries. This is what is called the boundary. In case you are given the boundary of your curve, like in this case, that is what is called definite integral. And it is written this way. For example, a to b of y with respect to. This symbol means we integrate function y with respect to dx from a to b. In this case, this is called definite integral. In the case now you are not given the boundaries, that is what is referred to as indefinite integral. So you have this example here. We have to evaluate this from 2 to 6, bracket 2x squared plus 3 with respect to dx. So to do that, first of all, integrate. How do we integrate? We integrate by adding the index with 1. So here we are going to have 2 plus 1, which is equal to 3, and we divide. So that is why here we have 2 over 3 x power cubic. Here it is x power 0 plus 1, which is equal simply 3x plus c. So we integrate this with respect to x. That is the first step. Then the second step is that we place the integral in a square bracket and insert the limit. So our limit is 2 to 6, as we have done here, 2 to 6. Then the step number 3, first step, integrate. Second step, place the boundaries and the bracket, square bracket as shown here. The third step which we are going to have is we substitute x is equal to 6 and x is equal to 2 here. So where you have x, you write 6. So you have 2 over 3 s cubic plus 3, 6 plus c. When you simplify, you are going to get, this is 118 divided by 3 times 2. 186. That is 6 times that. That is 6 times 3 is 196 divided by 3 times 2. You are going to plus 18. You are going to get 162. The other part, it is substituting x is equal to 2 there. Where you have x, you write 2 there. So 2 over 3 s cubic plus 3 times 2 plus c. You simplify and you are going to get that 4 over 3 plus c. Then from there, what you do now, you subtract the result of lower limit from that of the upper limit. In the other ones, we say 162 plus c minus 34 over 3 plus c. Of course, here, c minus c will cancel and we will be left with the 162 minus 34 over 3 to give us 352 over 3, which is the same as, this is an improper fraction, which can be written as proper fraction as 152 over 3, as shown there. Now, these steps can be summarized as shown. So instead of following all this, instead of following this long procedure, integrating, placing the bracket, substituting, subtracting the result of the lower limit from the upper limit, we can do it here in a summarized form as I have shown you. So first of all, you integrate this curve. How do you integrate? Always add the index 1 and you divide by the result. So you have 2 over 3 s cubic plus 3x plus c. Then you insert the lower limit and the upper limit in square bracket as shown. You substitute as shown there, and then you simplify as done here. So you simplify 162 minus 34 over 3, which is equal to 152 over 3. So that is how you use integration to solve an equation like the one shown here to get the value. So first of all, you integrate, substitute the boundaries, you substitute them, you integrate, then you insert the upper and the lower boundary on the square bracket as shown. You simplify and you get your result in a simple method as done there for you. We can use integration to find the area and a curve as shown here. In this case, we are taking that our area, it is beginning from x is equal to a from here, and it is ending at this point here. And our curve we are considering, it is x is equal to y is equal to x squared. So to do that, we simply integrate our curve from lower boundary, which is a, to the upper boundary, which is b. This symbol means integrate. That symbol tells you to integrate. When you see this symbol, it is the one which stands for integrate. X squared dx. So to do that, of course, it is very simple. You add 1 on the upper boundary, so you have 2 plus 1, which is 3, and you divide by 8. So you have x cubic divided by 3 plus c. You insert the boundary from a to b, and then you substitute to get your answer. So let us look at an example. Find the exact area enclosed by the curve y is equal to x squared, the x-axis and the lines x is equal to 2 and x is equal to 4. So x is equal to 2, it is the lower boundary, and x is equal to 4, it is the upper boundary. So to do that, always when you have a curve like that, it is necessary you sketch. So our curve is this one. When sketched, this is a curve of y is equal to x squared. Our lower boundary is 2, given here. Our upper boundary is 4, given here. Now, and the y-axis. The y-axis is this one, so you said that is the area required. So to do that, what you do, you integrate. So the area is given by integrating the curve. We integrate this function with respect to x, as shown here. So we simply integrate our function y with respect to dx. The lower limit is 2, and the upper limit is 4. Our y is x squared, this one, x squared dx, which is equal to, after integrating the 1 here, it will be 3, x power 3 divided by 3. Upper boundary is 4, lower boundary is 2. So here you substitute. 4 cubic, it is 64 divided by 3 minus 2 cubic is 8 divided by 3. When you simplify, it is 64 divided minus 8 to get 56, which is the same as 18, because 18 times 3 is 54 plus 2, 56. So that is the result, square unit. So that is how you can use integration to get the area under the curve. To get the area under the curve. The next part which you can be asked, it is the area under a curve and a line. Area under a curve and a line. So this one was the area. It was simply the area. This was simply the area under a curve. But now this other one, it is the area and a curve and a line. The area and a curve and a line. So I've given you an example here. We have our curve is given by this equation, negative x squared plus bx plus c, where c and b are a constant. And we have our line, which is given by our straight line, which is given by g of x is equal to mx plus c. That is our line. So how do we get the area here? That is what you want to see. So to get the area, what you do, you calculate the area of this curve by integrating this function. Then you subtract the area occupied by this line as shown below. So we are going to integrate the function f of x minus g of x with respect to x. We substitute them here as I have done for you. This is in bracket, one bracket. So you integrate the difference. So let us look at an example. Example, find the area enclosed by the curve y is equal to 9x minus x squared and line y is equal to x. So first of all, what you do, you sketch the curve. X is equal to 0 when y is equal to 0. So in this equation, you find the value of x when y is equal to 0. You substitute here. So to do that, you factor here. So you have 0, which is equal to x into bracket 9 minus x. So our possibility is that x is equal to 0 or 9 minus x is equal to 0. So that is what we are going to have. Meaning that our point is 0, 0 upper, 0, 0 here, or 0, 9 here. Those are our point. Now the line is y is equal to x. Line y is equal to x is this one. The curve is that after sketching. After sketching, because you have 0, 0 and 0, 9. The point, you have 0, 0, 0 and the point 0, 9 there. So to get the limit, finding the limit of integration, what is done is that you equate these two. You have y is equal to x, y is equal to 9x minus x. So we subtract the two. On the right hand side, on the left hand side, we are going to have y minus y is 0. 9 minus x, 9 minus x, it is here to give us 9x. You have x minus x squared, which is equal to 0. We factor x out. So x, this means that x is equal to 0 or 8 minus x is equal to 0. So x is equal to 8. So we are integrating from 0 to 8. This curve, 9x minus x squared. We integrate minus this other one. We have two functions, y is equal to x and y is equal to 9x minus 1. So integrate both of them. And when we do that, here we have, this is x squared divided by 2. 9 over 2 x squared minus x cubic over 3. That way, minus. We integrate this. This is x squared over 2. That way. And then from there now, we substitute the boundary as shown. So here we are going to have 9 over 2 into bracket 8. We square that minus 8 cubic over 3 minus bracket. When we substitute 0, this one will become 0. So that's why I have not bothered with that part. You have 8 squared over 2 minus 0, it will give us 0. So here we are going to have 9 times 2. This is 9 over 2 times 64 minus, this is 512 divided by 3 minus 64 over 2. This will give us 288 after simplifying minus 512 over 3 minus 32. Here we can get LCM. LCM of these numbers is 3. 3 divided by 1 is 1. 3 times 8 is 24. You write 4. 3 times 8 is 24 plus 2, 26. 3 times 2 is 6 plus 2, 8 minus 512 minus 3 divided by 1 is 1. 1 times 2 is 6. 3 times 3 is 9. So here we have 864 minus, this is 8. This is 8. 0. Carry 1, 6. So we subtract these two. This is 14 minus 8 is 6. 5. 8 minus 6, it is 2. So our result here, our result is equal to 256 divided by 3. You can leave that way or you simplify it. Look at now the application of integration in kinematics. Kinematics is the study of motion involving forces, but we don't consider external forces, we consider only the motion. So acceleration is given by change of velocity with the time. So to get velocity, what we do, we integrate velocity with respect to t. To get velocity, we integrate acceleration with respect to t, as shown here. This symbol stands for integration. This symbol stands for integration. So when you differentiate your function and you differentiate it, building and demolishing, building is integration. When you are differentiating, you are demolishing. So when you demolish and build, you get what we had initially. So our velocity is got by that plus a constant. Now, velocity is given by rate of change of displacement with the time. So to get displacement, we integrate the velocity. And again, when you are integrating and differentiating, you are going to get your displacement here, which is a vector quantity. That way. So this is mostly understood by giving a simple example. A ball is thrown upwards with a velocity of 40 meters per second. So determine an expression in terms of t for its velocity, its height above the point of projection. Now, here what you need to understand is that whenever you throw an object upward, the velocity will be negative because that object is moving against the gravity. So dv over dt give us acceleration, which is equal to -10. We take acceleration due to gravity as 10 for convenience. It is exactly 9.8, but for the purposes of convenience and calculation, we are going to take acceleration as -10. So to get velocity, we integrate this function with respect to t, and we are going to get v is equal to -t plus c. Now, initially, when the ball was thrown, the time was 0, and the velocity we are given it is 40 meters per second. So where you have v, you substitute with the 40, and where you have t, you substitute with the 0. So 40 here, v is equal to 40 initially, t is equal to 0. So negative 10 times 0 is 0, meaning that our c is equal to 40. You substitute here. So our v will be equal to negative 10, our c is 40. So we have answered Roman 1. The expression in terms of t for its velocity, it is that one. Now, change of displacement with the time is equal to our velocity, this one. ds over dt is equal to 40 minus 10t. So to get displacement, we integrate this equation with respect to t. And now we are going to have 40t minus, this is t squared divided by 2. T squared divided by 2. So we want 5 divided by 10, negative 10t squared divided by 2, we will get negative 5t squared plus c. Now, initially, at t is equal to 0, then displacement is 0. Before any time it elapses, then displacement is equal to 0. So use that condition. T is equal to 0 when displacement is equal to 0 to get our c. We substitute here. So 40 times 0 will give us 0. Negative 5 times 0 squared will give us 0. 0 minus 0 is 0. So c is equal to 0 because displacement is equal to 0 initially. So meaning that our s is equal to 40t minus 5t squared. So that is its height above the ground, above the point of projection. The height is given by s is equal to 40t minus 5t squared. So the maximum height attained by the ball, is given by v is equal to 0. So 40 minus 10t is equal to 0. So t is equal to 4. So the maximum height attained by the ball. So height is maximum when the velocity is 0. So we use this equation for the velocity. We equate it with the 0 to get the value of t. And when we equate this one with the 0, we are going to find it out from here. This is what we are doing. We are 40 minus 10t is equal to 0, meaning that 40 is equal to 10t. So you divide by 10 both sides to get t is equal to 4. So our t is equal to 4 seconds. Once you get your time as 4 seconds, the next thing now which you need to get is, the question is the maximum height. So you substitute here. Our time is 4. So 4 times 40 times 4 here is 160 minus 4 squared is 16. 16 times 5 is 80. So 160 minus 80 is 80 meters. So that is how you obtain it, and that is how calculus is applied in that is integration, application of integration in kinematics. So that is how it is easily applied and you get your answer. So thanks so much for your time. Let us keep on learning. This is calculus for beginners and it is applicable for grade 12. So I hope this video is beneficial to you. Kindly consider subscribing, liking and commenting, and even sharing with other scientists so that you can continue learning together. You can also share with me the areas which you think I should cover, and I will be willing to tackle them on your behalf as I meet your needs of mathematics. Thanks so much. See you next time.